Hello students, today we will discuss about problem related to oscillation under Coulomb force or under electric field. This channel provides you the physics lecture for class 11, 12, NEET and JEE in English version as well as in Bengali version. To see the unit-wise video lecture, go to the playlist of this channel. So here I will discuss all the possible situation of oscillation under Coulomb force or under electric field. So here is number 1. Number 1 is, suppose this is a circular wire. This circular wire contains charge of charge density lambda. So charge density lambda. So this wire is uniformly charged. Now this is the axis of this circular wire. This is the axis of this circular wire and this is origin. If this circular wire has radius r, so r is the radius of the circular wire, as of the circular wire. So if I place a charge minus q at a distance x from the center of this circular wire along the axis, then this minus q charge oscillate along this direction. You have to prove it. So number 1, you have to prove it. Number 1, the charge minus q charge will be oscillate. You have to prove it. Number 2, calculate the circular frequency or time period of this oscillation. Time period of this oscillation. This is the condition number 1. Condition 2, suppose a pendulum with thread, length of this thread is suppose L, and here is the mass M. If this pendulum oscillate under gravity, then the time period will be 2 pi root over L by G. This is the, if this pendulum is oscillate under gravity, then the time period will be 2 pi root over L by G. If this bob contains charge Q, and if I applied electric field along this direction, then you have to find out the time period of this situation of this pendulum. Number 2, if I applied electric field along this direction, so you have to calculate the time period in this condition of this oscillation. Number 3, if I applied electric field along this direction, so in this condition you have to find out the time period of this oscillation. Number 4, if I applied electric field at any angle along this direction, then this is 4. So in this condition you have to find out, this is 3, you have to find out the time period of this oscillation. This is the condition number 2. Now here I will discuss this problem, then I will discuss this problem. So now what is this? How you can prove the q minus q charge will be oscillate? So you take, it must be in this condition x less than r. So this length must be very small, this x must be very small. if if x is very small compared to the r, then minus q charge will be oscillate, and you have to calculate the time period of this oscillation or circular frequency of the oscillation. Let how this charge can oscillate, you have to prove it. Suppose you take a elementary distance ds, then this ds distance contains charge dq. The charge will be lambda into ds. So this charge and this charge will attract each other because this charge is minus and this charge is plus. So the force due to dq charge is acting along this direction. This is suppose df. So what will be the value of df? df will be 1 by 4 pi epsilon naught into lambda ds into q by, this is the distance. So if this is r, this is x, then it will be x square plus r square, then it will be x square plus r square. This is the force df. Then if I take angle theta, this is angle theta, then this df force can be resulated along this direction and along this direction. It will be df sin theta and it will be df cos theta. In the same way, if I take another same elementary distance ds, then this elementary distance contains same charge. For this same charge, this minus q charge will attract along this direction with same Coulomb force. Then if I resulated this force, then along this direction will be df sin theta and along this direction will be df cos theta. Here you see that this force and this force are equal in magnitude and opposite direction. So the net force due to this component will be 0. Now the total force, the total net force on charge q, on minus q charge due to the circular wire will be F net equals to integration df cos theta. If I take only df cos theta, then it will be close. That means total integration will be total path. Integration will be over total path of this circular wire. If I take 2 df cos theta, then you have to integrate over half path of this circular wire. So this is the F net. Then so if I put this value, that means total path, then df is 1 by 4 pi epsilon naught into lambda ds, here is q, by x square plus r square, and here is cos theta. What is the cos theta? This is the triangle and this is the theta. The cos theta means x divided by this. So cos theta will be x divided by root x square plus r square. So it will be integration, this value are constant. So q lambda x by 4 pi epsilon naught x square plus r square, and this value are constant, and integration of total path here is ds. So if I integrate, then it will be q lambda x divided by, here will be 3 by 2, here is 1, here it will be half, so it will be 3 by 2, so it will be 4 pi epsilon naught into x square plus r square 3 by 2, and here will be the total integration of this path. If this is r, then it will be 2 pi r, the integration value will be 2 pi r. So what will be the net force? Here is the net force F net force will be this pi cancel out, 1 is cancel out, here is, so this will be q lambda x divided by 2 epsilon naught, here another is, there is must be a r, and it will be x square plus r square 3 by 2. This is the force. And here you see that the distance x along this direction and force is along this direction, so it must be a negative. Why is negative? Because the direction of this distance is along this direction, so the direction of x along this direction and force is along this direction, so the net force will be, here will be a minus, so it will be minus. Now the condition is if r is greater than x, so what is the condition? If the distance x is very small compared to the radius of circular wire, then F net will be minus r q lambda x divided by 2 epsilon naught, here will be x is cut, that means here will be r q, so it will be minus r q lambda by, here will be r will be q lambda by 2 epsilon r square, 2 epsilon naught r square, here will be x, to lambda q lambda x by 2 epsilon naught, epsilon naught. This is the formula. Now what will be the total charge? Here will be the total charge, this is a lambda. If this total charge is lambda q, then lambda will be, if the total charge, total charge is q, here is the total charge is q, then lambda equals to q by 2 pi r, so lambda equals to 2 pi r. Then if I put this value, so if F net will be minus q x divided by 4 pi epsilon naught r q. This is the F net will be q x by 4 pi epsilon naught into r q. This is the force, total net force. You may calculate with the help of lambda, you may calculate the total charge of this circular wire. So F net will be along this direction. So if the mass of this charge will be m, then acceleration, mass into acceleration will be minus q x divided by 4 pi epsilon naught into r cube. So acceleration will be minus q x divided by 4 pi epsilon naught m into r cube. This is the equation. Now you see that, you see that the acceleration a equals to minus q x divided by 4 pi epsilon naught m r cube. This term is constant. So acceleration is proportional to minus x. Here this is minus x. For simple harmonic motion, for oscillation, simple harmonic motion, oscillation, the acceleration must be equals to proportional to minus omega square x. This condition is fulfilled. So the circular frequency omega will be root over this, that means q by 4 pi epsilon naught into m into r cube. This is the circular frequency of this oscillation. So using these two concepts, you have proved that the charge minus q is oscillate along this direction, because here is acceleration is proportional to the distance or the displacement and is opposite to this direction. So it obey the laws of oscillation. So this charge will oscillate along this direction. Now what will be the circular frequency? Here is the circular frequency is root over q by 4 pi epsilon naught into r square r cube. So omega will be what is the omega? Omega is 2 pi by t. Omega is 2 pi by t. So it will be root over q by 4 pi epsilon naught m into r cube. So t will be what will be the t? T will be 2 pi root over 4 pi epsilon naught m r cube divided by q into q. This is the time period 2. What is the number 2? Number 2 is condition number 1 is number 1. If the charge, a pendulum, this is the length of this, effective length of this pendulum, here is mass of the pendulum is m, it oscillate under gravity, then the time period of the oscillation will be 2 pi root over L by G. Now number 2, if the same pendulum mass m and contain charge q, this bulb contain charge q, if I applied electric field along this direction, horizontal direction, then what will be happen? So in this condition, suppose this is the condition, so in this condition the electric force will be along this direction, electric force will be along this direction. This is the force due to electric field. So due to electric field, and this will be the mg, this will be mg, this will be the mg. Now the acceleration due to electric field, acceleration due to electric field a e, that means for this condition acceleration is ae, then f of e equals to qe. This is force equals to mass into acceleration equals to q into e. So e equals to, due to acceleration due to the electric field, will be qe divided by m, and the acceleration along this direction is g. So in this case here you see that this is the acceleration g and this is the acceleration of due to electric field. So the resultant acceleration will be along this direction. Suppose this is g dash, this is g dash. So what will be the g dash? This is angle 90 degree. So g dash will be root over g square plus a square. So here is g square and here is q e divided by m whole square. This is the total acceleration for this condition. So what will be the time period? Time period will be 2 pi root over L by g dash. Here is root over L. What is the g dash? G dash is root over g square plus q e by m whole square. This is the time period of this condition. So here you see that if I applied electric field along this direction, then this bob, that means this bob pendulum of containing charge q, this pendulum experience a electric field of q_e. For this electric force, it has a acceleration. So due to this electric field, the acceleration will be q_e by m. So in this condition, the total acceleration, this acceleration due to gravity along this direction, the acceleration due to electric field along this direction, so the resultant acceleration will be along this direction, and the resultant acceleration, suppose g dash, so g dash will be root over g square plus a square. If I put this value, it will be this. So in this condition, the time period of this oscillation will be 2 pi root over L by g dash. Here you have put the value of g dash. This is the condition number 1. Now condition number 2. So suppose number 3, if I suppose this is the pendulum, this is pendulum. In this condition, if I applied, this is g, mg, this contain charge q and mass m. If I applied electric field along this direction, what will be happen? Here is, this is charge q, this charge due to this electric field, it will be the electric force along this direction. So acceleration due to electric field will be acceleration due to electric field will be AC equals to AE equals to QE by M, the same condition. But here you see that the acceleration due to gravity along this direction and acceleration due to the electric field will be along this direction. So total acceleration, the resultant acceleration g dash will be the sum of this acceleration g plus AC. So it will be g plus q e by m. So in this condition, time period will be 2 pi root over L by g dash. So it will be 2 pi root over, here is L and is a g dash, means g plus q e by m. This is the condition number 3. So if this condition number 4, if I applied electric field in this condition number 4, if this is the pendulum, so if I applied electric field along this direction, so in this case the mg will be along this direction and the electric force will be along this direction, F of E along this direction. So acceleration due to electric field will be AC will be QE by M, the similar condition. But here you see that the acceleration due to gravity is along this direction, the acceleration due to electric field along this direction. So the resultant acceleration will be the resultant acceleration, suppose G dash. So G dash will be G minus AC, because this is opposite direction. So G dash will be G minus QE by M. So this is the G dash. So here is T will be 2 pi root over L by G dash. So it will be 2 pi root over L divided by G minus QE by M. This is the condition, time period, if I applied electric field along this direction. Now if this is the condition number 4. Now condition number 5. Suppose this is a plate, 2 plate. This plate is positively charged and this plate is negatively charged. If I place a pendulum inside this plate, this is, suppose this is Q and mass is M, then you have to find out the time period of this oscillation. So if this is plus, this is minus, then the electric field will be along this direction. So for this condition, it will be the gravity, due to gravity force will be along this direction, and due to electric field, if this contains charge Q, then for this condition the electric field will be along this direction. The electric force is along this direction. The electric force will be Q into E. So acceleration due to these two path, then path AC will be QE by M, the similar calculation. Then here you see that the acceleration due to gravity is along this direction and acceleration due to this two path is along this direction, because if this is plus and this is minus, the electric field will be along this direction. So the resultant acceleration G dash will be the sum of this value. So time period will be root over 2 pi root over L by G dash. So it will be 2 over 2 pi, it will be L divided by G plus QE by M. This is the time period in this condition. So this is all the possible condition for oscillation under Coulomb force and electric field. If you do this problem, I am sure that you will be able to understand, or you will be able to solve any problem related to this oscillation. So learn